By the way, on number 12, you know, bless you, if you put your calculator in degree mode, I can't remember if I did this in the last video or not. Oh, I did it. Never mind. Never mind. 13, find the measure of angle A and angle B in the triangle. Round your answer to the nearest tenth of a degree. So I'm just going to start off by looking at angle A. And what I notice is that 13 is opposite of it and 18 is adjacent to it. Notice it says degree, all right? I know that the sine, sorry, not the sine, that the tangent of angle A is 13/18. What this means is that the measure of angle A is the opposite of tangent, is the arc or inverse tangent of 13/18. Probably half the student body is going to miss this question, and it's so easy. I don't get y'all. When we said you could be whatever you wanted to be, we meant it. But through your lack of effort, you are really narrowing down the things you can be in life. It's about 35.84 degrees. Now, if I have angle A, I can find the measure of angle B by taking away what I have from 180 degrees, because there's 180 degrees in a triangle. It's also alarming how many kids don't know that, but yet you guys are going to have offspring like crazy. You can't add or subtract, but you sure can multiply. 180 minus 90 minus the 35 and 8400ths that I have. Ta-da! 54.16 degrees. Now I think it says round to the nearest tenth, right? So I should have said that is about 35.8. If I can write. And this would be about 54.2. All right. 14. Evaluate the arc tangent of negative 6.45 such that the angle lies between 0 and 180 degrees. Mm. Mm. All right, first off, I'm going to talk about ASTC. All trig ratios positive, sine and cosecant are positive, tangent and cotangent are positive, cosine and secant are positive. For this to be negative, the angle is actually in one of these two quadrants. It lies in either quadrant 2 or 4 for that to be negative. Now let's see what a TI-84 tells me. Let's make sure I'm in degrees, by the way. I am cool. I hit arc tangent of negative 6.45. And this is what it returns. It returns negative 81.2 degrees. So by calculator, theta is negative 81 point, done forgot the decimal point, 19 degrees. Do you see the issue here? It's not stuck between 0 and 180. That's a negative angle that rotates like this. What we want is we want the positive angle which also wouldn't work. If we thought about the positive rotation here, we would have a much bigger angle. It'd be over 180 degrees. So I can't use it either. What I need to do is I need to realize that that reference angle could also exist here. Now, what I'm saying is there is an 81.19 degree reference angle in quadrant 2. The hard part for kids here goes back to how we draw angles. Angles start on the positive x-axis and rotate to a terminal side. So what I'm trying to find is this guy right here. And remember straight angles being worth 180 degrees? The actual angle that I'm interested in is 180 minus 81.19. This is a hard question for a lot of kids. It really is. I get why, because it requires more than just one simple thought. That's the reality of it. It's multi-step. It ends up being 98.81 degrees. Now check this out. Let's take the tangent of that angle. I bet it's really close to negative 6.45. Pretty cool, huh? All of them were. Like I mentioned one earlier, that one right there, its problem was that it was bigger than 180, but check out its tangent ratio, negative 6.45. So use that. I'm trying to give a hint there without telling you what the hint is. All right, moving forward, evaluate the arc sine of negative root 3 over 2 such that the angle lies between 0 and 2 pi. A question like this is literally pure unit circle. I'll show it both ways, but it can be done with a unit circle. A lot of it depends on, have I taken the time to memorize the unit circle? All right, now sine psi y. Where is y negative root 3 over 2 on unit circle? There's a couple of places that happens about right here and about right here. There we'd be 1/2 negative root 3 over 2, and back here we would be negative 1/2 root 3 over 2. Now where does that happen in, well, all right, so in degrees that happens at 300 and 240. Of course, I want radian answers, right? I need radian answers. So 240 degrees as a radian is 4 pi over 3. 300 degrees as a radian is 5 pi over 3. Now watch this. We got negative root 3 over 2. All right, let's put my calculator in radian mode. The sine of 4 pi over 3 is that decimal, and the sine of 5 pi over 3 is also that decimal. You may not fully comprehend what I'm trying to show you here, but I am showing you something about doing things without knowing how to do things. All right, now the classical approach to this one is a little bit different. This is the triangular approach. And that's just for kids who have not bothered to memorize the unit circle. So the triangle approach is to realize that this is negative. Think about ASTC. Tangent and cotangent are positive, which means sine is negative. Cosine and secant are positive, which means sine is negative. And what we do is we draw triangles in these quadrants. The ratio is given as opposite over hypotenuse, so the hypotenuse on this guy is 2 on both of them. And the opposite length would be the negative root 3. This is supposed to be a pattern we recognize. It is. If you don't, it's because you just don't want to memorize. These are 30, 60, 90 triangles. That's a pattern for a 30, 60, 90. Of course, I put things in the wrong spot there, didn't I? Got ahead of myself there. My 30-degree angle was in the wrong spot. 30, 60, 1, 2, root 3. So opposite of a root 3 is going to be a 60-degree angle on both of these. Now, the thing is what these are reference angles. And here's one of the things that just bothers kids, all these multi-steps to doing things. The actual rotation to get there to the first triangle in quadrant 3 was 240 degrees. The actual rotation to get to the second triangle was everything but 60. It was 300 degrees. And you know what? Let's go old school since I don't have the circle memorized. I take my 240 degrees and I multiply it by pi over 180. I take my 300 degrees and I multiply it by pi over 180. And say I'm horrible at fractions. 240 times 1 over 180, I just don't use the pi. I just put the pi back in place. Math, enter. 4/3, don't forget about pi. Same thing over here. It'd be 5/3, don't forget about pi. So there's two approaches to doing it. You pick your pill, red, blue pill, blue pill, do not care. Just pick the one that gets it right. 16, given that the tangent of alpha is negative x and alpha lies in the fourth quadrant, find the sine of alpha. So I'm going to draw a triangle in quadrant 4. Everything in this universe is divisible by 1. Even infinity, everything is. Even 0. The tangent is opposite over adjacent, so opposite of alpha. I'll just put alpha prime here. And you really can't tell what that is, just whatever. It looks like a bow tie now. Opposite of this bow tie is going to be a negative x, and adjacent to this bow tie is a positive 1. We're going to do a little Pythagorean theorem here. A negative x squared plus a 1 squared should be the hypotenuse squared. That'll give me x squared plus 1 is c squared, so c is the square root of x squared plus 1. Of course, you can't do anything with that. Now, I did all that to find the sine of alpha, because the sine ratio is opposite over hypotenuse. Opposite of alpha is negative x. Hypotenuse, root x squared plus 1. And that's as far as you have to take it. Not a hard problem. All right, 17, Alex props the ladder against a wall. The ladder makes a 27-degree angle with the ground. If the ladder is 22 foot long, what is the expression for finding the distance the foot of the ladder is from the wall? Of course, ladders do have feet, believe it or not. Most of them, some of them do, not all of them. Now, ideally, a ladder leans. You are welcome to put a ladder straight against a wall and try to climb it. If you do that, please record it for me so I can laugh at you hysterically as you fall. But this ladder is 22 feet long. It forms a 27-degree angle with the ground. And I want to know how far the base of this ladder is from the wall. So I'll just call that x. And x's relationship to the angle is adjacent, and 22, of course, is the hypotenuse. And it's just a good old SOHCAHTOA problem is all she is. And you'll notice it's this guy right here. It's CA. The cosine of 27 degrees must equal the adjacent side over 22. And we just go through the algebra that we would do to solve this thing. We just multiply both sides by 22. And that's the answer. Choice A. 18, write the inverse of h of x is 3 tangents of x minus 2 plus 5. So it's been a minute and you guys forget everything. First step, swap x and y. Step 2, resolve for y. Step 3, notation. 3 easy steps. That's all it is. All right, so this is h of x, which is just fancy for y. It becomes an x. We get the h out. We have an x. She becomes a y. And now we're at step 2. I resolve for y by doing the easy stuff first. I'm going to take away 5. X minus 5 equals 3 tangents of y minus 2. Before I even worry about arctangent, I worry about the opposite of multiplication, which is division. So x minus 5 over 3 is now the tangent of y minus 2. The opposite of tangent is called arctangent. So I take the arctangent of both sides. If you don't know what the opposite of tangent is, you look at your TI-84 faceplate and it'll tell you in blue. Now what happens is tangent and arctangent knock each other out of the park. They annihilate each other. So my next line looks like this. The arctangent of x minus 5, sitting pretty over 3, is simply y minus 2. All I have to do is counteract subtraction through addition. And the arctangent of x minus 5 over 3 plus 2 is y. Notice where I added the 2. I didn't try to add it inside because that's an argument. And then the last step is notation. The inverse of h of x would be written as h to the negative 1 of x. Read the inverse of h of x. Not too bad. All right, I think up next is the bonuses. Maybe you'll do them, maybe you won't. Bonus one is something that you learned about in geometry. In geometry, you were supposed to learn the law of sines. And the shorthand version of this says the sine of angle A is to side A, as the sine of angle B is to side B. So what I'm looking at here, and I can, by the way, finish out this triangle. There's 180 degrees in a triangle, right? 180 minus 55 minus 43. That's 180 minus what, 98, which I think is 82 degrees. I see 82 down here, so maybe I'm right. I have a side angle repair here. The sine of 43 degrees would compare to a length of 42, as the sine of this 82 degrees right here would compare to the unknown length, which I'll just call x because I'm comfortable with x's. Then we're going to do something old school called cross multiplication. X sines of 43 degrees would be equal to 42 sines of 82 degrees. Remember, we're solving for x here, so the only move we have to do is to divide out the sine of 43. So I'm looking for, apparently I have some typos here, 42 sines of 82 sitting over the sine of 83. It looks like when I wrote these things out, for some reason I put 44s in here. They should be 42s. And that ends up being choice C, doesn't it? I need to fix that. Let me pause this real quick and fix that. All right, I fixed it. Okay, so moving on to the next bonus here. Students struggle reading this. It says one of the angle measures in the triangle is arctangent of B over A. So I know that the tangent ratio is opposite over adjacent, okay? To have a B over an A, I'd have to be talking about this angle right here, opposite over adjacent. Think about that. I've got B as opposite. I've got A as adjacent. So the angle of interest is going to be this guy right here in the corner. There's my theta. Now I want to know the sine of the arctangent of B over A. Weird, huh? I want to know the sine ratio of this angle. That's what it's saying. It says, what is this angle's sine ratio? That's the actual questions being asked here. So to do that, I know that I've got to have opposite and hypotenuse. And I have the opposite. It's a B. I'm going to make that uppercase even though I shouldn't. Otherwise, it's going to look like a 6. And that's just going to confuse the crap out of some of y'all for some reason. Where do you get a 6? I don't know, bro. You've been with me 9 months. Figure it out. We're going to use an old theorem that says a squared plus b squared is c squared. And I have no idea what a and b are, which is okay. All I got to do is take the square roots of both sides. And don't you be the dum-dum who thinks that's a plus b. The square root of a squared plus b squared is not a plus b. That makes no sense. If you think that makes sense, you're not mathematically oriented and you need to fix it and figure out why not. But this is the hypotenuse. I should be putting it on the outside, but I'm just out of room. It ought to be right there, right? Anywho, this is my hypotenuse. Square root a squared plus b squared. That's your answer. It's actually a really easy problem. All right, bonus 3. Consider a 6-bladed wind turbine with blade lengths of 75 feet. There's some formulas here that I didn't teach because I ran low on time with you all this year, so that's why they're bonus questions. All right. Now, if you think about what you have here, you have a wind turbine. Let me do the blades first. I got to have 6 blades, and presumably they're all roughly equally spaced. Okay. If you think about rotation here, that would make each one of these angles 60 degrees. And you got, of course, it's a wind turbine. 6 blades, 60 degrees. Which you can't really tell it because of the way I oriented that one there, but that's a blade right there. Find the arc length between each blade. Now, arc length is, for some odd reason, called S. and it has a formula of r theta. The disclaimer here is that theta is a radian. Now, I would expect if you're doing bonuses, you probably know what 60 degrees is a radian. 60 degrees is a pi over 3 rad. It's a pi rad. So the blades are 75 feet long, and if they spun, you would outline a circle. So they would represent the radius of the circle. So the arc length is simply 75 times pi over 3, which is just 25 pi over 3, because 75 divided by 3, boys and girls, is 25, and I don't need the over 3 part. It's just 25 pi, and this would be in feet. Be 25 pi foot. Find the area between each blade. Now that would be called a sector. That's what we call this. We call this a sector. All right. The area of a sector has a nice little formula. It's 1/2 r squared theta. And again, theta is a radian. So our radius is still 75. Our angle is still going to be pi over 3. By the way, I didn't really tell you all what arc length was. I'm assuming you know. Arc length would be how far it is from here to here if you travel the circle. That's what we call arc length. An area would be what it takes to paint or cover the territory in between those blades. And there's really not a whole lot you can do with this thing. This has to be squared. This would be a pretty hideous number. Let's see what it looks like without pi in it. 0.5 times 75 squared. And then let's do 1 over 3. See if we can get a nice exact answer. So it's 1,875 over 2. And don't forget about pi, because I never put pi in the calculator. So I got to put it back on a piece of paper now. Square feet. All right, there you go. Bonus 5, solve the equation. This is one of those things too I intended to get to, but it just didn't happen because of time constraints. Solve 2 sine squared plus 3 sine theta plus 1 is 0 over the interval from 0 pi to 2 pi. So one of the first things I'm going to do is I'm going to use something called u substitution. I'm going to write this as 2u squared plus 3u plus 1. What I did is I let u be the sine of theta. And the reason I did that is because this is easy to factor. It gives me 2u and u to make 2u squared. Factors of 1 are 1 and 1. By God, if I do 2u times 1, I get 2u. 1 times u, I get 1u. 2u plus 1u is 3u. Still equal to 0. Let's go ahead and put our u back in place. 2 sine of theta plus 1 times the sine of theta plus 1 is 0. Now we're going to use ZPP. 2 sines of theta plus 1 is 0, or the sine of theta plus 1 is also 0. All right, let's do the easy stuff. We're going to subtract 1. 2 sine of theta is negative 1. Divide by 2. The sine of theta is negative 1/2. Or the sine of theta is negative 1. These are straight unit circle questions. They are. Remember, psi y says where is y equal to negative 1? Right here. That's 0, negative 1. The angle of interest here is 3 pi over 2. So one of my thetas, and actually I'll call this theta 3, she's 3 pi over 2. Good? Maybe? Who knows? Here it's where is y equal to negative 1/2. The two locations that y is equal to negative 1/2 are about right here and right here. This is at 7 pi over 6 and at 11 pi over 6. So I get some more thetas. I get 7 pi over 6 and I get 11 pi over 6. Thing has 3 answers. Oddly enough, the reason it has three answers is because of the cyclic nature of trig. And there you go. Drops the mic. Good luck on your test.